Okay. So we have discussed a more complicated case like this example number 2. Yes, we have, sorry, this not. So we have this example number 3. Yeah? We have discussed an example, more complicated one, to calculate all of the currents in the circuit. Okay. I will continue the discussion today if we have a capacitor in the circuit. Okay, so this one is capacitor. Okay, so if only the capacitor, in this case, this is without R, without the resistance or internal resistance of the capacitor, then the capacitor will charge, C will charge simultaneously. Simultaneously. Simultaneously, say this one. It means that there is no interval time, this delta t is equal to 0. Okay. So if the C after fully charged, yes, then for example, the current only at this direction, let's say. Okay, but there is no current here. Is E1 equal to 0? Okay, because the capacitor is already charged and is already fully charged, so there is no current crossing the capacitor. Okay, let's say this is the point AB, C, D, E. Okay, let's say we have R1, capital R1 is 2 ohm, R2 is 4 ohm. This battery, we have potential source. Yeah, the potential is epsilon 1 is 2 volt and epsilon 2 is 4 volt. Okay. What is the current in here? So we could take a loop. For example, loop D, A, E, F, B, C, D. Okay. This one. So what happened? This one, this epsilon, yeah, this second Kirchoff law. So we have, the potential, yeah. So this one, D, A, E, F, B, C, D. Okay, we have epsilon 1, okay. And this is minus epsilon 2, okay. Because this is, sorry, this is minus plus, minus plus, okay. And then we have, so because the loops, yeah, is the opposite, is clockwise, the direction of loop is clockwise, but the direction of the current is counterclockwise, okay? So we get this is minus I R1 minus I R2. Oh, sorry. Okay. So it means that we have minus I R1 plus R2. So if we put, if we take the value epsilon 1 is 2 minus 4 minus I 2 plus 4. Okay, then we get, what we get is I, this is minus 2, so this is 2 over 6 here. So let's say, okay, ampere. Okay. So our assumption that, the first assumption that the direction of the current is correct, okay? Because we have positive value in this case. Any question? Any question? Hello? Any question?
No, sir.
No, sir. Okay. Clear, yeah? Okay. And how about the potential difference? VAB. What about VAB? VAB equals to VA minus VB. If you see from oh, sorry, should be C. C, let's say, I forgot. Let's say C, let's say 1 farad, okay? Just take this 1 farad. It's very big capacitance, yeah, 1 farad. So what is the potential difference between A and B? In other words, the potential difference between, in the capacitor. Hello, how to calculate it? Hello, hello, anyone? Riandito.
Yes, sir.
Yeah, how to calculate the potential difference between A and B?
We can just use the equation, sir.
Sorry?
Hello?
Yes, yes.
Hello, hello.
Hello, yes, yes. Please answer the question.
We can use We can use VIR, sir.
IR, okay.
We find the voltage at
How?
A and
How? So, okay, maybe it's too technical. Okay, let's say I will ask which potential is greater, VA or VB?
I think it's at A, sir.
A. Okay. Reno. Hello,
Yes, sir.
Reno.
Yes, sir.
Yeah. Which one the potential is greater, VA or VB?
I think VA as well, sir.
VA, okay. Nicholas Aryandra,
Yes, sir.
which one the potential is greater?
I think VA, sir. The
VA.
potential, right?
Yeah,
I think VA.
VA, okay, thank you. Celine, hello?
Yes, sir.
Can you ask Firda, he's in waiting room. Is she late or having problem with the connection?
Okay, sir.
Andravati. Which one
Yes, sir.
is
Yes, sir.
greater?
I think it's also at A,
At A.
but I'm not
Okay.
sure. Yeah,
You're not sure.
yeah, I'm not sure.
Sultan. Hello, Sultan.
Yes, sir.
Yeah.
I
Give your
think
answer.
in A2, sir. A.
A also. Okay. Okay, let's see. You see that we have positive current, okay? 1/3 ampere. So which one is the direction of the current? So from the picture, from the figure, you see that this current flows from B to A. So the current flows from B to A. What it means? What does it mean? It means that VB is greater than VA. Okay? Because the flow is the direction of positive charge. Okay? So charge flows or moves from positive to negative, or from positive to neutral, or I mean the potential is lower. Okay, so the answer is the VB is greater than VA. Is that clear?
Yes, sir.
Okay, let's calculate it.
Sir,
Yes.
sorry to interrupt, but Firda said she had some difficulties with her laptop.
Okay. Okay, thank you. It's already okay. Okay, okay, thank you, Celine. So let's calculate which one, VB, okay? This VB sorry, Celine, can you ask Hamadi and Arasha, Bimasena, they're having a connection or they are late?
Okay, sir.
Okay. let's see, phi b equals to, just like yesterday, this is a minus I R2, yeah, plus epsilon 2 plus VA. Okay. So this equals to minus 1/3 times R2. Which one is R2? R2, 4. Plus E2 is 4. Okay. Plus VA. This will be 8/3 VA. So phi BA equals to 8/3 volt. Okay, so this is minus phi AB. So phi AB equals to minus 8/3 volt. Okay.
Sorry, sir.
Okay. So how about the charge? The charge in the capacitor, you just so there is C times phi. Yeah? Okay. So this equal 1 phi AB. This is phi, okay, phi BA, let's say, phi BA. Positive 1, 8/3. So this is 8/3. Sorry, this is column, okay? This is column. The units, this is the capacitance. Sorry, yeah, I mean, I have to use the same symbol.
Sir,
Yes?
Arya Bima Sena said he has a bad internet, and for Hamadi, he just finished cleaning his room.
He just what?
He just finished cleaning his room.
Cleaning his room.
Yes.
Okay, thank you.
Okay, sir.
Yeah. Anything else? I mean, any question?
Sir.
Yes.
Oh, so for the VAB, it is minus because the flow is from BA. So is it right, sir?
Sorry.
So the VAB is minus, the voltage is minus because it shows that the current flows from BA.
Yes. Yeah.
So, yeah. So if the assumption of the loop is wrong, the voltage would be minus. Is it right, sir?
Yeah. Exactly. Yeah.
Okay.
You could also compute the other way around. I mean, from this one, you can also you should get the same result if you use this one for this
Okay.
one.
So I have one more question, sir.
Yes.
So previously you asked about whether V in B or A is bigger. So
Yeah.
we cannot know which one bigger after we calculate, or we can.
You should calculate. I mean, you can guessing, but in the at the end you have to calculate.
Yeah. Okay.
Okay.
So-
let me just a moment. Let me open the lecture yesterday. Which one? Sorry. I think I have used the same convention, yeah. So this like this one, VB. Okay, this is we get negative. This is plus, and this is minus. So this is the from the lecture yesterday. Okay, so okay, yeah. Sorry.
Thank you, sir.
Yeah. Yeah. Okay. What is it? Okay, okay. This one, yeah. Okay, this is minus IR. Okay, this is plus. Okay, that's correct. Yeah. Anything else? Okay. Okay, then we go to the second example. There is resistance here, resistor. What is the difference between the first and the second? So because we have a resistor, the capacitor C will charge, well, not simultaneously. Okay, but the interval time is not exactly 0, but it very fast, such that it's very small, the interval time. So it means that at the beginning, there is current. This current called transient current. Okay. Why it is called transient? Because it will be disappeared. Okay, we will discuss this transient current after this. Okay, but usually if you face this problem, for example, in the examination, usually commonly we have assumed that the capacitor is already fully charged. So usually there is assumption. Capacitor C is already fully charged. So because it's already fully charged, this I here, because this is I, is equals to 0. Okay? Then if we take this assumption, okay, we have the same execution, yeah, how to solve this problem. So exactly the same as the first example. you can calculate that you will get this I, for example, if this is I1, for example, this I1 is 1/3 ampere. Okay. And if you calculate VBA, it's also the same. 8/3 volt. Charge is also the same. Column. Okay. So the source of the potential difference is coming from the capacitor, okay? Because we have zero current in this point B to A to B or something like that. Okay, anything else? Any question?
Sorry, sir.
Yes?
So does it mean that the resistor R3 doesn't affect anything in the calculation?
Yeah, because
Okay.
the potential difference of the resistors will arise if we have non-zero current, okay? If the current is zero or vanishes, if the current vanishes, then there is no potential difference in between the resistor on the resistor, okay? So the potential difference in R3 is zero because I is zero.
Okay.
Yeah. Anything else? Okay, let us continue to this called RC circuit. The main discussion of this subsection is about what I have said today, just now, is about transient. Transient mean, let's say, well, this current will be disappear if for a very long for a very long time. Okay, I mean transient means temporary. Let's say temporary. Temporary. Okay, let's see. If we consider okay, this is a switch. S is a switch. Okay, we have this epsilon, this is R, and this is C, okay? So if the switch off, then there is no current. If we if we take the switch on, okay, if this is on, then we have non-zero current, okay? So from the second Kirchoff law, we have this epsilon equals I times R plus the potential in at the potential at the capacitor. Okay, so this is equals to IR plus Q, let's say Q over C. Okay, this is a constant also. Constant. Are also constants. Okay, so from this equation we also have the Q over dt. Okay, we can use this one, or we take the derivative. We differentiate this equation. So because this is a constant, there will be 0. Differentiate equation, this one is star. Okay, with respect to t. So this is 0 equals I dt R times E over C. Okay. So we will have this di dt plus I over RC equals 0. So the solution of this first order differential equation is something like this. 0 e to the minus t over rc. This I0 here is initial current. Does it mean that initial current, usually if we take t equals 0, at 0 second, we have I0 equals I0. Okay. So you see that at t equals to 0, we have I0. But if we take for a long time, it means that t goes to infinity for a very long time. This IT will goes to 0. Okay, it means that this is a transient current. Sorry. Okay, any question? Any question? Okay, what about the charge? You see that this I equals to the Q over dt. Okay, there should be QT is integral I dt plus C. Okay, so you see that from this form, the solution, this should be the integral, should be dt this is 1 over minus 1 over RC. Sorry. Okay. E0 e to the minus t over RC. Sorry, this is, let's say, C1 plus C1. Sorry, this is a integral constants. Constants. Constant integration. So we get this QT is minus RC I0 e to the minus t over RC plus C1. Okay. In the contrast of compared to the current, at t equals 0, this Q0 is 0. So we get that 0 equals to minus RC I0 plus C1. Okay. So this C1 equals to RCI0. So we get this QT is RCI0 times 1 minus e to the minus t over xc. So this one can get that this is Q0, okay? Sorry, not Q0, Q maximal, sorry, is Q maximal. Okay, why is maximal? Because we have at t equals 0, this is 0, but if t goes to infinity for a very long time, the capacitor will reach its capacity, then the charge of the capacity equals to Q max. This is the maximum charge that will be filled the capacitor, okay, at the end. So at the end, this transient current will be 0, okay? Then there is no current in the circuit, in this case, for serial RC. Any question? So this is in the case, I just want to say that at t equals 0, the capacitor C is empty. It means there is no charge in the capacitor, okay? As t goes to infinity, the capacitor will be fully charged, okay? So you see that from this case, from this formula, okay, if you take R goes to, let's say 0, okay, take to the 0, then it goes to infinity, then this is 0, and this is because there will be 1 here. So there is Q max times 1, okay? Anything else? Any question? So if this is the case, we call it charging the capacitor. Charging the capacitor. Charging the capacitor. Okay. So the second case, we will discuss about discharging C. Discharging the capacitor C. Okay, so this is the opposite case, yeah, from the first example. The second example is about discharging the capacitor. It means that at t equals 0, at the beginning, the capacitor is already fully charged. Okay, it means we have Q, let's say, Q max at t equals 0. Okay, second, t equals 0 second. So the circuit will be like this. We have this R here. We have this C is already fully charged. Yeah. We will also have this I here. Okay. So from the second, this one, the second Kirchoff law. Okay. This one, yeah. This is because epsilon is 0, then we get only, in this case, we get only I capital R plus Vc equals 0. Okay, so this the Q over R plus Q over C0. Get this dQ dt plus Q over RC equals 0. Oh, sorry. Okay. Okay, the solution in this case will be at Qt is Q max times A minus T over RC. Okay. So if we differentiate once again, it will be the Q over the T. So this will be Q max, sorry, Q max times minus sorry, 1 over RC e to the minus T over RC. Okay. So this will be I minus Q max over RC e to the minus T over RC. Okay, so this is equals to I0, okay, at T equals 0. This is the initial current. So it should be equals to I0 A to the minus T over RC. Okay, that's about the transient current. Any question? Any question?
So I have a question about the quiz.
Sorry?
I have a question about the quiz.
The quiz? Which
Yeah.
quiz?
The faculty quiz.
Oh, the faculty quiz will be this week, yeah, on Saturday, I think. Saturday or?
Yeah, it's Saturday. So for the materials.
Sorry?
For the materials, what is going to be in the quiz?
Okay, I will summarize today's lecture in bahasa Indonesia ya. Jadi hari ini kita sudah bahas tentang rangkaian dengan kapasitor ya. Jadi pertama, jadi kalau misalkan di sini ada kapasitor gimana gitu ya. Nah, jadi kalau kita lihat di sini, ini dia kapasitor tanpa hambatan R. Ini artinya bahwa nanti ketika saklar dinyalakan, itu kapasitor itu akan langsung terisi muatan secara penuh. Gitu ya. Jadi karena tidak ada hambatan di situ. Jadi arus transiennya bergerak bisa dikatakan secara simultan gitu. Jadi delta T sama dengan 0. Jadi kalau ciri kalau kapasitor tersebut sudah terisi penuh, itu tidak ada arus yang mengalir. Jadi tinggal tegangan saja. Gitu ya. Jadi artinya keadaan akhirnya itu akan jadi seperti ini di gambar ini. Nah kalau Anda lihat, ya, dan kalau Anda lihat di sini, dia punya tegangan ya. Tegangannya itu VAB ya, atau VBA lah yang positif lah ya gitu. Jadi kita menghitungnya seperti ini ya dengan konvensi yang kemarin. Jadi kalau dia ketemu arus, walaupun dia itu arus ketika dia itu searah dengan ketemu resistor, dia minus. Kemudian di sini plus ketika kita ketemu dari B ke A, mana tadi? Bukan yang ini ya. Oh, yang ini, sorry, maaf. Yang ini, jadi ke sini kan dia itu minus, karena dia itu kan hambatan. Terus kita ketemu suku positif di sini, negatif di sini jadi plus. Konvensinya seperti itu ya kelihatannya. Itu kita ikutin yang kemarin ya, sehingga kita dapatkan memang VB kurang VA itu adalah 8/3 volt. Oke. Kemudian kalau dia itu kita tambahkan kapasitor, ya, jadi sebenarnya nanti yang mempengaruhinya cuma waktu terisi muatan saja, artinya tidak simultan lagi, tapi butuh waktu tertentu gitu ya, dia tidak simultan, tapi delta T-nya sangat kecil. Nah, dia akan ada arus awalnya, itu kita sebut namanya arus transient. Arus transient. Dan arus transient itu ada sampai kapasitor terisi penuh. Nah, nanti jadi tinggal di tegangan antara A dengan B itu cuma dari kapasitor saja. Karena dari resistor itu tidak ada, kan dia tidak ada arus. Jadi kalau tidak ada arus ya berarti tidak ada tegangan gitu ya. Seperti itu. Kemudian kita ngebahas tentang rangkaian RC. Nah, di rangkaian RC ini kita ambil tentunya yang paralel, yang sederhana gitu ya. Jadi kita dengan menggunakan hukum kedua Kirchoff kita dapatkan seperti ini persamaannya. Ya. Jadi Anda pecahkan, Anda turunkan lagi terhadap T, Anda dapatkan seperti ini. Kemudian Anda harus merumuskan menyelesaikan persamaan yang ini. Jadi persamaan yang ini itu kita dapatkan IT di sini adalah I0 ya, I0 pada T sama dengan 0. Oke. Yang disebut namanya transient current atau temporary current lah. Arus yang sementara. Kenapa sementara? Karena ketika waktu yang sangat lama yaitu T-nya akan menuju T-nya menuju tabringga, I-nya akan menuju 0, IT-nya. Oke. Nah, jadi seiring dengan arus itu 0, arus itu berkurang lah intinya gitu. Justru muatan itu bertambah di situ. Jadi muatan itu bertambah. Gitu. Bertambahnya gimana? Ya itu tadi. Jadi ketika T sama dengan 0 kan kapasitornya kosong. Ketika T-nya menuju tabringga dia terisi penuh muatan, itu yang Qmax ini. Itu yang pengisian kapasitor, kita sebutnya charging kapasitor. Kalau discharging itu pengosongan kapasitor, itu awalnya biasanya kapasitornya terisi penuh. Oke, sehingga yang menjadi sumber arus nanti itu adalah kapasitornya. Nah, kalau di sini itu bisa dikatakan untuk muatannya kapasitor itu awalnya terisi penuh, tapi seiring dengan berjalannya waktu dia akan mengeluarkan muatan menjadi arus gitu di rangkaian tersebut. Nah, karena muatan itu keluar dari kapasitor, maka dia akan berkurang. Nah, jadi makanya Qmax-nya ini itu ini adalah keadaan kapasitor pada T sama dengan 0. Oke. Kemudian kalau saya turunkan lagi, karena Qmax itu pas keluar dari kapasitor itu nanti akan menjadi arusnya juga itu arus transien. Gitu. Jadi, tapi perbedaannya di sini arusnya itu awalnya tetap ada, walaupun nanti pada akhirnya menghilang ketika kapasitor itu tidak ada lagi muatan listrik gitu, di dalamnya. Mungkin itu aja dari saya, terima kasih. Kamis kita libur ya, tapi Jumat kan enggak ya, jadi insya Allah Anda kumpulkan apa istilahnya namanya PR ya, hari Kamis karena udah saya setting, nanti hari Kamis tersebut akan saya kasih modul keempat, Anda kumpulkan seperti biasa gitu. Jadi kerjakan nomor 6 sampai 10, kumpulkan hari Kamis jam 12 malam, jadi 23.59 PM. Oke, itu aja dari saya, terima kasih. Selamat siang semua, jaga kesehatan.